Welcome back to Advent of Code 2016. Hello, Maro. Hello, DIJ. Alright, so far ChatGPT has been beating us every single time, as I half expected. So on to day 5. How about a nice game of chess? Doesn't look like it's about chess. Alright, so, of course that's a War Games reference. I gotta watch War Games again. It's been a long time. You are faced with a security door designed by Easter Bunny engineers that seem to have acquired most of their security knowledge by watching hacking movies. Let's have a look at this. What hacker movies are there? Oh, this is a link for hackers. Never seen it. The 8-character password for the door is generated 1 character at a time by finding the MD hash of some door ID and an increasing integer index. Okay, pretty sure in Python you can do MD5 hash with easily. Hash indicates the next character in the password if its hexadecimal representation starts with 5 zeros. If it does, the 6th character in the hash is the next character of the password. Are we basically mining Bitcoin here? This is the principle behind mining Bitcoin. You try to find a SHA-256 hash which starts with like a certain number of zeros. And if you're the first one in the world to find that, then you get the coins. Sounds like you have to code a hex tree. One of these days we might actually need a hex tree, whatever that is. I guess it's just a binary tree, but with 6 children instead of 2. Okay, so if the door ID is ABC, the first index which produces a hash that starts with 5 zeros is that. Starting from 0. So we keep increasing until we get to like 3 million? Alright, seems like it might take a long time. Which we find by hashing ABC. So we take the door ID, we put the number afterwards, hash that. If it has 5 zeros, then the hang on. What becomes the character of the password? The 6th character in the hash. The hash was... Oh, they're not showing the hash. Okay, fine. But they're saying it's 1, so you get a 1. Okay. Fine. Then you start again from 0. And so here, the next password is 8. Okay, fine. This is just a straightforward for loop and with an MD5 hash. Okay. And you do that 8 times. Okay, so this is the input. Okay, fine. Right, how do we do MD5 in Python? Well, okay, let's take the... Okay, so we've got door ID equals that. I need to zoom in a bit. Okay, so one password equals just an empty list. So we go for car in door ID. We want to say no. We don't go through the. Oh no, that's not how we do it. So we go while we haven't found 8 characters yet. So while length of password is less than 8. So we start with index equals 0. So let's say to hash equals door ID plus, just add the index to the end of it. Then we do the hash. How do we do this? I've got to go Google this. Python MD5 hash. Import hashlib. Hashlib.md5. Okay. Okay. If hash dot starts. Wait, hash is going to be. Oh, I see. So we need to encode. Wait, this, you have to do this to encode it into bytes. Okay, and we get back. Dot hex digest to get it as a. Okay, let's try printing this. I'm not sure if I'm using the right types here. Okay, that's fine. If hash dot starts with, and then we want 1 2 3 4 5. Password dot and hash five. Okay. Index, increment the index, and then finally we want to print join password. All right. I don't know how long this will take to run. It has to go through indices until it finds. See, if it's random, which is it is roughly random, then the chance of 5 zeros being at the start of the hash will be 1 in 16 to the power of 5. Ah, okay, here we go. 2414BC77. Okay. I mean, that was actually... I mean, if you understand what MD5 hash is, and even if you don't, that's actually one of the easiest problems, to be honest. Because you don't really have to do anything to do literally what they're saying step by step and put it into code. Those kinds of problems are the easiest, even if it looks a bit scary throwing all these terms here, but it's... You just do literally what they're saying in order. You don't have to do anything smart. It did run quite quickly, yeah, I guess. So, let's see. 1 in 16 to the 5. I don't think that's how you... No, we want to do 1 in 16 to 5. It's small, but it's... So that's like 1 in 100,000 or something. It won't take that long. MD5 hash is pretty fast to compute, so it won't take that long to find the next index. But yeah, that's interesting because that's basically what Bitcoin mining is. You just use SHA-256 instead of MD5. Take a bunch of transactions that people want to do. People want to send this many coins to so-and-so. You take a bunch of them, you put them in a list, you hash that whole thing, and if you are lucky enough to get like 20 zeros at the start, then you publish that. You say, I just found a transaction list with 20 zeros. You broadcast that to the network, and everyone agrees that you were the first, and so you get the coins. Which now would be like, you know, like $100,000 or something. What is the Bitcoin difficulty right now? The difficulty says how many zeros you need. T8.71T. What? Don't understand what that means exactly. But yeah, at certain intervals they increase the difficulty so that it's actually harder to mine. Okay, next part. As the door slides open, you are presented with a second door that uses a slightly more inspired security mechanism. Clearly unimpressed by the last version. In what movie is the password decrypted in order? The Easter Bunny engineers have worked out a better solution. Instead of simply filling in the password from left to right, the hash now also indicates the position within the password to fill. You still look for hashes that begin with 5 zeros. However, now the 6th character represents the position 0 to 7. The 7th character is the character to put in that position. Okay. So, for example, if we got 5 zeros, a 1, and an F, that means F will be the character for the password, 1 will be the position to put it in. Okay, I get that. You almost choke on your popcorn as the final character falls into place, producing the password, blah blah blah. Okay. Given the extra door ID in this new method, what is the password? Be extra proud of your solution if it uses a cinematic decrypting animation. Well, I've never really dealt with animations in Python, but maybe one day. Alright, this... Just a slight added change to this, but doesn't look difficult. So... we say... So the same loop as before. If it starts with... I think I might need some library for that. Well, it could do ASCII, but I don't... Well, I can't do... It can't change ASCII on the spot. It can print line by line in the console, so I don't think there's any way for it to really do animations without a library. Alright, so... Position equals hash 5. If pause in, let's say, 0, 1, 2, 3, 4, 5, 6, 7, and... Oh, wait, hang on. So this time, password will have to be none times 8. So we want while none in password. So keep going until we've filled in all the nuns. So if the pause, which will be the next character after the zeros, is one of those numbers, and password is already none, then password will be set to hash 6. That's it. Oh, I shouldn't have modified this. I always wanted my code to do both. Alright, doesn't matter. One after the other. Okay, so it's warning me, but it's fine because there won't be nuns in the password anymore. Wait, int pause is a character, so that's fine. It doesn't like me doing that because I'm being naughty, but it'll work. It'll work. So it'll take a little bit longer because it's going to sometimes get pauses which are out of the range, which will happen like half the time. And it will start, as we start filling in the password, it's going to be hitting duplicates where there's already a character set in the password. So that's going to extend the length of this a bit. By a factor of like 8 times log 8, so about 100 or something. Oh, okay. Correct. Yeah. I assume most languages have MD5 libraries. If it didn't, then you're then you're in trouble. Yeah, okay. Let's see how ChatGPT fares. I feel like ChatGPT will understand this. It's pretty understandable, and they didn't even throw in too much lore or Easter Bunny stuff, so it's probably that probably makes it easier for it to understand. Okay, let's say... I can tell it what my input is, so it can actually give me the full program. So let's write like this, say, can you write a Python program to solve the following program? My input string is... Okay. So he's using hashlib, of course. Door ID, password. Yeah, I mean that's pretty straightforward. Dot encode. Don't think you even need to bother putting the UTF-8 there, but it is actually probably the more correct way to do it. One small complaint with what he's done. If you take an empty string and you keep adding characters to it, it's not efficient because you completely have to rebuild the string every time. Which, I mean, for 8 characters doesn't matter. For longer strings does, because you're starting to use quadratic time having to do that. The way I did it was to have a list, because a list can be incremented at constant time, and then tie up the list as a string. But, I mean, I think he recognizes that for 8 characters, it doesn't matter at all, so... I used starts with, he used this, because they're both equally fine. I like starts with because it's just more readable. Oh yeah, okay, I'll do that next. So, yeah, at the end of this, I'll say, can you now give me the same program in Brainfuck or something? I'll see if you can do it. Well, Brainfuck, I don't know if it will have MD5, but... Okay, let's try this. So he might try to do MD5 from scratch in Brainfuck, which would be horrible. Alright, so this should just run. You might be right, actually. I think they have set it to refuse inappropriate requests, but we'll see what it does. Yep, that's correct. It is a language name, but I think they might set some auto filters to automatically refuse requests involving fuck or anything like that. I wouldn't be surprised. Like, they're being really careful with media attention right now because they're in the spotlight. So I wouldn't blame them. And it's an esoteric language. It's not something that anyone actually really uses. So, okay. Can you adjust the program for this? Hang on, let me... Alright. So what did I say before? Can you change the problem for the following specification? Let's see if he does something cinematic. Wait. He's changing the... Can you change... Oh, I should have said program. He's changing the problem. Wait, let's see what he does here. Yeah, no, he's just printing back the what I did, but he's actually cleaning it up a bit. He's putting bullet points in and... Okay, fine. Oh, okay, so he's also solving it. Nice. So he's using isDigit and, yeah, equally good. To make it more cinematic, you can add some code to display a decryption animation while the password is being calculated. Cool. At least he addressed it. All right. Just... All right, just run it. But I'm pretty sure that will work. Four, 3, 7. Yep. Of course. All right, let's see. Can you solve the same problem using... Let's tell him it, the programming language, just to emphasize it. Sometimes people use an exclamation mark instead of the U. I could do that if he doesn't like it. Okay, he's happy to talk about brainfuck. This is ridiculous. Okay. I wouldn't be surprised if it's actually correct. I was watching a YouTube video the other day by Asmongold, the former World of Warcraft player who now just does lots of YouTube videos. He was talking about RuneScape and how a lot of people are creating bots in RuneScape that walk around and use ChatGPT to talk, but the code the prompt they give to ChatGPT is specific. They tell them avoid mentioning like bot or ChatGPT or anything, and they say also make your grammar a little bit broken in places, so like a RuneScape player would talk. The result is crazy. You see bots having conversations with other bots, and they were suggesting that RuneScape, the company, might actually just flood their game with bots just to make people feel like there's more people around. I wouldn't be surprised if they do that, and they probably are already doing that, to be honest. Yeah, I've noticed this before. I think if the programs are too long or it gets too confused, it just stops. I don't think it's done though. It does sometimes just freeze. Maybe with a paid version that wouldn't happen, but yeah. Well, okay. Well, that's something. We could tell him what would be a simple problem that could be solved in Brainfuck. Can you write a basic FizzBuzz is the classic interview problem. FizzBuzz program in Brainfuck. So FizzBuzz is where it's like you count the numbers 1, 2, 3, but every time it's a multiple of 3, you say fizz, and every time it's multiple of 5, you say buzz, and if it's both, you say FizzBuzz. Companies always like asking that problem because a surprising number of people, even if they're strong programming developers, get stuck trying to write that. While he's commenting this is nice. For April Fools, we released a trailer for Azadreams where we were suggesting that we're going to add ChatGPT to Azadreams. It was pretty funny. I could show that now, actually. What, just that ChatGPT bit? Not as long as I thought it would be, but I guess this is a problem which is a bit more natural for Brainfuck since it revolves around moving a head across a ticker tape. Wait. Actually, okay, cool. Cell 3 is 0, move to cell 2. How many instructions are there in Brainfuck? Is it just all that we see here? 1, 2, 3, 4, 5. It's like 5. There's a full stop as well. I don't know what that does. 6. Is it 8? Okay. Yeah, I guess the idea is supposed to behave like a Turing machine, which is the most basic computer, and Turing machine is just like there's a physical head. It moves back and forth across a tape, and every time it stops, it looks at what the number it's looking at, and it increments it or decrements it. I mean, in computational theory, you start with that idea of a computer, and you prove that everything can be done. Everything we do can be done on a Turing machine. It's cool stuff. So yeah, I would say that's another win for ChatGPT, but it was close. I solved it in roughly the same amount of time, but I mean, he still solved it quicker. Alright. Signals and noise. Something is jamming your communications with Santa. Fortunately, your signal is only partially jammed, and protocol in situations like this is to switch to a simple repetition code to get the message through. In this model, the same message is sent repeatedly. You've recorded the repeating message signal, your puzzle input. I've noticed they like a lot of cryptographic or code-based problems in this 2016. You've recorded the repeated message signal, but the data seems quite corrupted, almost too badly to recover. Almost. All you need to do is figure out which character is most frequent for each position. For example, if you had recorded the following messages, the most common character in the first column is E, in the second A. Yeah, okay. Yeah, there's a whole theory in cryptography about decrypting noisy signals, where you know that noise can be applied with a certain probability, then you can kind of invert it and find what is coming up most commonly, and then that's how you filter out the noise. This is proper cryptographic theory. Error correction. Okay, fine. My input. So just find the most common letter for each list. I wonder if you can do Shakespeare language. I mean, I don't think anyone ever created a compiler for Shakespeare language, but there is this. It does look quite funny. Let's see if I can find it again. No, Shakespeare programming language. Because it was like, it's quite smart though, because so you use enter and exit to create variables or deconstruct variables. And it's like the number of adjectives you use, like this one, fatherless, big smelling, half-witted coward. That's how you increase or decrease numbers. Well, this is how you describe integers. So each adjective is multiplying it by 2. You are as villainous as the square root of Romeo. But the thing is, it's ambiguous because you have to interpret it according to these rules. That no one's actually created a compiler for this, I think, because it's not really easy to. Because you can write anything, it just has to follow certain rules, and there's like negative adjectives and positive adjectives. Like rotten is a negative one, but that's also somewhat up to opinion. So. You are as cowardly as the sum of yourself and the difference between a big, mighty, proud kingdom and a horse. Speak your mind. Speak your mind is supposed to mean like print. Print your value now. Right, so we want go back to reading the input. So let's say we enumerate. So how many characters are there? 1, 2, 3, 4, 5, 6, 7, 8. So basically, let's just create 8 counters. So from collections import counter, which just does what we want. It creates a count for each letter. Counters. Okay. With open for line, so we want for I car in enumerate line.strip. So counters I that'll get us the ith counter, and we want the car as the key. We want to increment it by 1. And then we just what are we doing? Oh yeah, the message. So message equals, let's just say empty string, or C in counters. The most common letter equals the max of the keys where we're comparing on the count value. So key equals lambda k maps to ck. So it'll basically pick the key for which ck is maximized. I don't know if there's a more concise way of writing that, I'm not sure. Message.append common print is that it? But I think it's supposed to be an actual English word or something, isn't it? Does that look right then? Common, it's the max amongst keys. Looks correct. Maybe that's the message then. I don't know. I thought it would just be a proper, like, natural language message, like Easter or something. But yeah, because they're randomizing the input for competitors in this, so I guess they wouldn't. Yeah, okay, that makes sense. Of course, that would be the message if you hadn't agreed to use a modified repetition code instead. In this modified code, the sender instead transmits what looks like random data, but for each character, the character they actually want to send is slightly less likely than the others. Choose the least common letter to reconstruct the original message. So we just change max to min. Okay. So we can just do this. Literally just max to min, and I'll take the minimum. Okay, is that it? Easiest part too. Okay, so let's start a new chat. So we want to say my input will be in input.text again. Oh. How did I phrase it before? Yeah, like this. I need to make a script that just kind of auto copies the text from here, puts the prompt at the start, can you do blah blah blah, submits it to ChatGPT via the API, gets back the code, runs the Python code. I mean, that's probably what the competitors are doing, to be honest, who are getting the top of the leaderboards these days. All right. So you use zip. Yeah, I was thinking about using zip. Frequencies equals... So that's just a one-liner without having to have a... store a bunch of counters. That is... I would say that's less readable, but that is actually probably better, but... Key equals f.get. That makes more sense. Okay. Let's test this. Yep, it's fine. Modify. Okay. Can you modify the code for the following specification? Takes into account the new decoding methodology. Should just really be the same. Just change literally just that max to min. Yeah. And it explains it well as well. Okay. AOV. Yep. Right. Day 7. Internet Protocol version 7. While snooping around the local network of EBHQ, you compile a list of IP addresses. IPv7, of course. You'd like to figure out which IPs support TLS, Transport Layer Snooping. An IP supports TLS if it has an Autonomous Bridge Bypass Annotation, or ABBA. An ABBA is any 4-character sequence which consists of a pair of 2 different characters followed by the reverse of that pair, such as XY, YX, or ABBA. However, the IP also must not have an ABBA within any hypernet sequences, which are contained by square brackets. So yeah, they're deliberately making this, making the description a bit confusing, but it's okay. So basically, you're taking a string and you're saying it's valid if outside the square brackets. But can they have more than one pair of square brackets? Possibly. Or we could check the input. Okay, so it has to have an ABBA outside. Well, it's IP7. Okay, so it's going to be that size, or no, it's not. Let's have a look at the input. Oh yeah, there are multiple square brackets. Okay, fine, we could deal with that. And within any square brackets, there shouldn't be any ABBA. So this one's invalid because it has an ABBA in the square brackets. This one has no ABBA outside the brackets. Alright, it's just parsing it. It's a bit weird. What's the easiest way to parse square brackets like that? You can... Well, you can't really use split, but... You can use regex, but it'll take me ages to write a regex for that. Alright, let's just... start with something. Like, okay, regex, I'm not sure how to... Actually, I don't think this is regexable because it's an unbounded number of square brackets, so... I'm not sure how to deal with that. Well, it'll be like... I think it'll get too messy. I think I can just deal with it by iteration. It seems like it's never more than 2, to be honest, but could be. All right, so all right, just take the well, it's always okay. It's always alternating between outside, inside, outside, inside. So if we just tokenize it by splitting on bracket characters, then it will always start with outside, it seems to, and then alternate like that. That's how we do it. So tokens equals line.strip.split. So like that, just it splits on either of those characters. Let's have a look. I think that'll work. No, that's splitting on that string. Of course it's splitting on that string. How do I... There's things you can do with split, more complex things. Using sep. I don't think you can do what I'm trying to do. I want to split on either. All right, well, there's a cheat we can do. We can say dot replace that bracket with that bracket, and now split on that. There we go. So we need a method to determine if something is an ABBA or not. So what exactly is an ABBA? It's a string which has the full sequence somewhere in it. Okay. Okay, so define is ABBA of an arbitrary string. Okay, for I in range, let's say so we finish on the index like 4 positions from the end, so that'll be length minus 4. So we do length minus 3 to include that one. So to check if word equals s from I to I plus 4. So we need if word 1 is not equal to word 0. So the second character has to be different, and word 0 is the same as word 3 and word 1 is the same as word 2, then immediately we say this has an ABBA, so we say true. Otherwise, return false. So we need to say if any is ABBA S for S in tokens where we skip all odd numbers. So it's going to be that 2, 0, 2, 4, yeah. So if there's any ABBA in those tokens and there is not any is ABBA for S in tokens. So we go 1 to 2, so that's the odd ones. What are we doing again? Counting how many, okay. Oops, almost spelled a bad word there. Alright, as long as the logic of my ABBA is correct here, should be fine. 105. Correct. You would also like to know which IPs support SSL, super secret listening. Okay. An IP supports SSL if it has an area broadcast accessor, or ABA, anywhere in the supernet sequences. And a corresponding byte allocation block, BAB, anywhere in the hypernet sequences. Okay. So an ABA, let's say ABA, is 3 characters in the form XYX. Okay. And BAB. Huh? Oh. Oh, damn. Okay. We need an ABBA with a corresponding BAB. Phew, okay. So... okay, it's gonna just be one chain of 4 loops, to be honest. Just for each ABBA we find in outside the brackets, we then search through all the inner brackets if the corresponding BAB exists somewhere. Okay. Yeah, this is an interesting twist. It's not quite trivial to change to part 2. This one needs a slightly different structure. So we don't want an is-ABBA method because we need to know the letters. So let's do this again. All right, so let's say for let's create a method. Define. Let's use the terminology they used. What was it? SSL is SSL given a set of tokens. Right, so or okay, basically this for each of the outer strings, we go through all 3 letter combinations and see if it's an ABA. A-B. Okay, so for so we get word equals 3. So we say if, how is it going to work? Basically this. If the first is different from the second and the first is equal to 0 is 1 is not equal to 0 and 0 equals 2. Okay. Then let's set A and B to be the letters. So A equals word 0. B equals word 1. So now we need to find BAB. This will be easier because we don't have to, we can just look for that substring. So BAB will just be B plus A plus B. So we found an ABA. Now we have to just check across all the, if any, so it's basically similar to this. If any BAB in token in S or S in all the inner tokens, we immediately return true and we're done. We've found one example. Otherwise, return false. Okay. 258. Correct. All right. Yeah, that was a nice change to part 2. Not too hard, not too easy. All right, let's have a look. Okay, let's see if ChatGPT can do this. I'm interested to see how he handles the parsing here. It could use regex, but I'm not sure exactly how you would capture it easily. I mean, I would say this is one example where regex, the complexity of regex sort of outweighs the usefulness for this problem. I think the way I did it was probably actually the simplest. Supports TLS. Is hypernet equals false? Has ABBA outside hypernet equals false? Has ABBA inside hypernet? Okay. Oh, he's doing it as a... Okay, fine. As a... going through the characters, character by character. I don't really like that way of doing it. It's just harder to wrap your head around, but I preferred splitting it into tokens. Then I can use the any methods that I used. But it looks correct. Alright. $105, yep. Alright. This is... Come on, I want to see him fail for once. Oh, okay, switch the window. Alright, so... Part 2. I think he'll be fine with this. If he understood the first one, the second one is clear enough. Even with all this jargon. Supports SSL, so now he's... creating a list of the tokens. So he's essentially tokenizing it now because it's easier to deal with. If any ABBA in BAB for BAB in hyper... Ah, so he's finding all the BABs and all the ABBAs and comparing them. That's also a valid way to do it. That's actually more efficient than what I did, because then you don't have to... Then you're skipping... You're finding all the ABBAs, all the BABs, and then you have a reduced set to do the quadratic comparison with. Whereas I'm doing a quadratic comparison with every possible 3-character string, substring of the hypernets. Whereas he's restricting to only the BABs. That's actually a significantly more efficient way to do it if you're using large data sets. Right, just gotta test it. Oh? You got 42. Too low. He's made a bug, but we'll give him a chance to fix it. Alright, let's say... have a look at this again. I wonder what the bug is. Okay, I can't really check all these indices, but right, we'll just I don't know what the bug is, but we'll tell them there's a bug. There is a bug. It is giving me too low an answer. No, I think we need to tell him to fix the bug. He's asking us how to debug it. He's telling us how to debug it. I want him to solve it. I think this might be the first fail. But I'll give him another chance, because I mean, it's still not spent much time. Length IP address -2. Okay, fine. Oh, has he actually found the issues? Well, let's try that then. Oh, sorry, I didn't have the window shown. So this is what I was doing. I said, I originally said, there is a bug, it's giving me too low an answer. And then he just told me how to debug it, but then I was like, no, you do it yourself. There is a bug as the answer is lower than the correct answer. Can you identify and fix the bug? He seems to have found 2 bugs. Or potential bugs. It's giving me new code now. Oh. I was supposed to just change the supports SSL method. Keep the printing. Alright. 0. Alright. I mean, it's worse. He's made it worse. This is worse. Now I am just getting 0. One last chance, ChatGPT. Worse. Worse, not words. So we need to change supports SSL to this. Still incorrect. No, you failed. I had a feeling he would fail on this one, if any of them. I don't know exactly why. I think it's just it's a slightly bigger change from part 1. Even though it's described quite concisely. I don't know what his bug is. I'm not really that interested to find it because it'll take ages, but okay, we'll give him one last chance, but this is the last chance. He might not have just might not have understood the problem. Why is it -2 here? What is... 0 equals 1. That seems... Yeah, it's unless I go through it line by line, I can't really debug this. No, let's just try this one last time. I don't think he gets the problem fully. So he's probably solving a slightly different problem. Which is not surprising. That was actually a pretty convoluted description for a problem and threw in lots of jargon to throw him off. Still 31. Tell it that it's useless. Oh, I can't do that. I'd feel bad. I'd actually feel bad. I'll give them feedback on this. I'll just say... Let me click. Wait, what? What do these buttons do? Okay. Just say didn't correctly solve the problem. Oh, he's trying again. Give it up, ChatGPT. Okay, they want me to put feedback here, so I'll do that. But I'm not counting this as a win if this actually works. Nope, still doesn't work. Neither answer is better. Interesting. I don't know what the... I can't work out what his issue is, but I mean, the code looks sensible. The important thing is that he's comparing ABBAs with BABs and checking that they're equivalent. But that was a fail. So, okay. It's 6-1. 6 wins for ChatGPT. 1 win for me. All right, 8. Problem 8. You come across a door. Are all these problems just doors in this HQ? Right. You come across a door implementing what you can only assume is an implementation of a 2-factor authentication after a long game of requirements telephone. To get past the door, you first swipe a key card. Then it displays a code on a little screen, and you type that code on a keypad. Then presumably the door unlocks. Unfortunately, the screen has been smashed. After a few minutes, you've taken everything apart and figured out how it works. Now you just have to work out what the screen would have displayed. Oh, it's some sort of pixel thing. The magnetic strip on the card you swiped encodes a series of instructions for the screen. The screen is 50 pixels wide and 6 pixels tall, all of which start off, and is capable of 3 somewhat peculiar operations. Rect AB turns on all the pixels in a rectangle, which is A wide and B tall. Okay. Rotate row. Oh, rotations. Rotate row Y equals A by B. Shifts all of the pixels in row A right. Oh, it's not a geometrical rotation. It's just like a translation across the row. Okay. Pixels that would fall off the right end appear at the left end of the row. Right. Rotate column. Shifts all of the pixels in column A down by B pixels. Fine. So you create a rectangle, you shift the column down, you shift right. There seems to be an intermediate check of the voltage used by the display after you swipe your card. If the screen did work, how many pixels should be lit? So basically we apply this and just count how many pixels are lit up. Interesting. So you don't need to do anything smart for this, I guess. You just need to just do these steps, because it's a small grid, it's not big, and there's not many instructions, so it's not going to take too long to run. Alright, so the grid is 50 wide, 6 tall. Okay, grid equals, so we'll just say zeros and ones. So 0 for in range 50. Okay. Okay. These could go up to 2 digits. So let's say if line dot starts with rect, we need x and y A and B, let's call them A and B. No, X and Y is more familiar, right? X, Y equals, so we want line.split first to get the 1 by 1. So we take the second thing in that. Then we split by the X character. So that'll get us two numbers. Int Z for Z in. That should get X and Y. And now for I in range Y, for J in range X, grid I, J set to 1. All right. Elif. All right, so now we deal with the row. Row in line. So we need the Y value and the shift value. Okay, so tokens equals line dot split. What, is my computer slowing down or something? Okay, line dot split. So the row will be tokens one, two, three, 0, 1. So the tokens 2 dot split on the equals, just avoiding regex here again, and then take the parameter 1, interfy that. And the shift will be int tokens. It'll be the last token. Yeah. Now what? So we want to take the, want to replace the row by the shifted row. Well, that's not too hard. So wait, it shifts which way? To the right. So you'd end up with the last shift characters being at the front. So you'd actually get new row equals row minus shift onwards. Does that work? Plus row up to minus shift. So if you shift 1, we'll take the 1 character at the end, put it in front. Yeah, okay. Then finally just do grid, row, grid. Hang on. No, row is... row is replaced with new row. Alright, bit confusing. And then finally deal with the column, basically the same principle. Column will be column. So it'll be the same locations. The shift, yeah. New call. So let's say column equals, let's just extract these. Grid I call for I in range. Well, how big is this grid? It's 6. So new call will be column all right, and then we need to replace. So just do it manually. For I in range 6, grid I call equals new call I. Let's just see what this looks like now. For row in grid, print row. Okay, it's doing something. Well, row in, so we want to count the number of ones. So count plus equals sum of row. Okay, I think the logic is correct, but all of this syntax here, I don't know, I could have made a mistake somewhere. 115. Correct. Okay, good. You notice that the screen is only capable of displaying capital letters in the font it uses. Each letter is 5 pixels wide and 6 tall. After you swipe your card, what code is the screen trying to display? Yeah, so what we need to do now is reverse. Hang on, so wait, hang on, I'm trying to understand the order that things happened here. So they say the screen's broken. Do we actually just want to print the final? So you follow these instructions. So we just need to print what it looks like, and it will look like digits, won't it? If not, then maybe I need to reverse. Hang on. I haven't quite understood how this works. If I print it. Right, we need better. Let's say hash for 1. And empty space. That will make it easiest to see. Like, do we see a letter appearing here? Yeah, I think that's an F. Or, no, that's an E. It's too hard to read right now. Okay, let's do grid equals, let's say, empty space. And, okay, here we change this to hash. And then the shift doesn't need to change. And then here, keep this working by saying row.count hash. But we print the joined up row. There we go. What on earth does that say? To squint my eyes a bit. EFEYKFR. Okay, it's not a word. All right, fine. EFEYKFRFIJ. All right. How's ChatGPT gonna handle that? Well, I mean, we can ask ChatGPT just to print the display. I mean, ChatGPT doesn't do OCR, optical character recognition. Correct. All right. So. Okay, let's do the first one. So as long as, yeah, okay. The commands is, as long as he understands the command, the format of the command. They did specify it, so. So he's done starts with rect, like I did. Map. Yeah, he split it up the same way I did. He's going zeros and ones, as I did. Rotate row. How's he done rotate row? Same thing I did, of course. Rotate column. Kind of similar, right? All right. Let's test this out. $115, correct. All right, now how do we deal with this? Well, if he realizes that he just has to print the display and then we'll be able to interpret it. Okay, so I'm not sure whether he'll be able to figure this out though. All right. Okay, just this. So he's printing it, and he's using hash and dot. What the? Whoa. No way. No way. Will this work? Thing is, we don't know. He's assuming he knows. But they might not have adhered to this positioning of the characters, though. But they might have. I don't know. It's like there's not a unique way to write an F, is there? You could make the second bit a bit shorter or longer. But if he adjusted it to find the closest fit, then it would work. Like, find which of these is the closest map. Oh, it's not finished. He's trailed off. That happens sometimes. How do I see? The program's a bit long. Okay, let's just say, can you show me your main method again? You didn't finish it. Alright, so if we just copy that chunk there, like I would be surprised if this works, because it has to match exactly. But it would have. I would be really impressed though if he wrote kind of an error correcting thing, so find whichever those is closest, and that would work because the letters are all different enough. Oh, he's also looking for numbers as well. He shouldn't though, because, well, yeah, you can if you want to. Oh, this is his main method. Okay, so we want that, and then we want the main method afterwards. Wait, so is he using decode char? Well, anyway, I mean, this will correctly solve it if we can identify it by eye. So let's see. And so you read the instructions, create the screen. Wait, what's screen? Oh, he's actually doing. He's actually using a graphics library. I mean, I have. What is it? Is it Oh, Turtle. Turtle is a graphics library included in Python. I forgot about that. My compile. Let's tell him my compiler doesn't recognize screen. Yeah, well, of course I didn't define screen. You have to define it for me. Okay, class screen. Put that in. Well, he's giving this as a All right, let's try and regenerate this decode thing because that didn't finish. See, he was on the right lines here. I just want to see how it would have finished. All right, maybe he'll finish this time. Okay, he's finished. This might actually work now. All right, yeah. It prints the letters. So I can do it visually. I wanted to try his decode cow thing. Let's see if we can get him to regenerate that properly. So let's say, can you provide the full program which will automatically identify the characters, the closest fit characters in the display. No, I don't want. Oh, he's doing it visually again. I mean, this is a pass. I can do it by eye, but I want to see if he can actually do what he was trying to do earlier. It just, the code didn't finish. Oh my god, he's using Hamming distance. This is Getting somewhere. Please finish. Yeah, hamming distance is a metric for comparing the display with the... I think it's because I'm scrolling up, it's somehow interrupting him. Damn, this was good. Alright, let's just not touch the screen. I don't know, it must be a bug or something. Let's just wait. I think when you scroll up, for some reason it interrupts him. He's not using hamming distance this time, he's using... Oh, I think that is hamming distance, he's just defined it manually. Yes! Finish the program. Alright, this is it. Let's test this. This is insane if this works. Oh. Do I not have NumPy installed? Okay, just quickly install it. Man, this looks very... So if you were doing live competition, you wouldn't have time to code this, like, hamming distance thing. You would just do it visually, but he's just done it, like, a full program, which gets you the answer. List index out of range. Okay, so it prints the final screen, so that gives you the answer, visually. Just tell him it's giving index out of range. It must be very close, but... server down or something. No, I know. Wait, stop. I don't want you to tell me how to debug it myself. Alright. Includes error handling to avoid the index error list. Okay, fine. Maybe we'll still get the letters and then the error occurs after the final letter because he wasn't expecting a certain size of something. Match score. Best match score, oh my god. Oh, he's designing characters now. Visually, that's cool. Oh, he's making them look really weird though, the A and the D. Oh, it's too long. I think either I need to use a different browser or maybe I use the API to fetch the results because I think there's an issue with using it in Firefox maybe. It just kind of trails off and it doesn't finish. Oh, will we actually get... a result here? From typing, import list. This is where it might trail off. It's insane. Oh, no. It's just... they're not worse. Sane. Okay, whatever. Yeah, I can believe that would actually work, that method, but you can't finish it. I might have to try it again in Chrome or something. I don't know. Upgrade to Plus. How much would Plus cost anyway? $20 per month? I wouldn't want to pay that much for it unless I found some sort of major use for it in streams and programs and stuff. $20 a month is too much for what I'm using it for right now. Okay, well, that's still a win. He was able to print it visually, so... so yeah. Crazy. So out of 8 problems, only one of them I think I've outperformed ChatGPT on, in that he couldn't really solve it. Alright, that's enough for today. Let's tell him goodbye. Okay then. That was problems, what, 5 to 8? They all seem to revolve around cryptography. I guess that was the theme of this month. I mean, I would like if they change it up a bit. I don't really want to be doing cryptography for all 25 days. I imagine, and lots of people don't really like cryptography, which is fine, but I imagine those people would get quite annoyed if it was the entire month. I do like it, but I still want variety in the month. All right, we'll see how it goes. All right. Thanks for watching, Maro and DJ. I'll see you next time for more Advent of Code 2016.